Here in this video, we will see a problem of an inclined circular plate which is immersed in water. For that, we have a question here. A circular plate 3-meter diameter is immersed in water in such a way that its greatest and least depth below free surface are 4 meter and 1.5 meter respectively. Determine the total pressure and position of center of pressure. So this is the question which we have. Whatever is given here, I'll write that in the form of data. A circular plate 3 meter in diameter. So the diameter of the plate D is equal to 3 meter. From the diameter we can get the value of area as well. So area of the plate will be pi by 4 D square. D is 3. So this value comes out to be 7.068 meters square. After getting area of the circular plate, it is immersed in water in such a way that its greatest and least depth below free surface are 4 meter and 1.5 meter respectively. Now, the greatest depth is equal to 4 meter and least depth is equal to 1.5 meter. Determine the total pressure and position of center of pressure. This is the question in front of us. Whenever they are saying total pressure, it means hydrostatic force. And position of center of pressure, it means location of hydrostatic force, that is H star. Now with these data available, let us try to get the solution for this problem. And for that purpose, here I have already drawn the diagram. I'll explain what I have done here. Since we have liquid as water, and in that we have a circular plate whose diameter is 3 meter, which is immersed. Now the greatest depth, it was given as 4 meters. So here the circular plane, it means it is inclined. Greatest depth is 4 meter and least depth is 1.5 meter from the free surface of water. This free surface acts as a reference. From these free surface we are measuring the distances. So least depth is 1.5, greatest depth is 4 meter. Now after that, here H bar, this H bar indicates the position of centroid, and we know that for a circle centroid will be there at the center. So this centroid I have projected here, and the distance of the centroid from the free surface is H bar. Now as we can see, this plate is inclined at an angle of theta. So this case becomes of an inclined plane which is kept in water, and there would be a force exerted on this plate because of the water, and that force would be called as hydrostatic force or total pressure. So in solution, I'll write down, since total pressure or hydrostatic force is given by the formula of total pressure is rho g area into H bar. I'll keep this as equation number 1. Now for the calculation of hydrostatic force, rho is the density of the liquid. Here liquid is water. The density for water, rho, is equal to 1000 kg per meter cube. This value is constant for water. G is 9.81. Area, we have already calculated it in the data of a circular plate. Only unknown is H bar. It means once we can get H bar, we can find the hydrostatic force. After this, I'll say that therefore, now as we see here is H bar, we can say that this 1.5 meter distance up to this height, if I project it, by a dotted line. This much distance from the free surface till this dotted line, that is 1.5. This distance we know. Now the only unknown here is this small vertical distance. If I can get this value, I'll add 1.5 in that and get the answer of h bar. So now what I'll do here, in this case we know that this is 4 meter and here we have 1.5 meter. So I'll get this height, that is 4 minus 1.5. This height would be 2.5 meter. Next, here I have this diameter as 3 meter. So now what I'll do here, I'll get the value of theta. I'll say that therefore from the geometry of figure alongside, I'll draw this triangle again. This angle is theta. Here I'll say that this is triangle A, B, C. Now distance B to C is known to me, that is 4 minus 1.5. So this distance is 2.5 meter. Next, AC is the hypotenuse, which is the diameter. Here I have this as 3 meter. Now I can get the value of theta from this. I'll say that since sine theta is equal to opposite upon hypotenuse, BC upon AC, so therefore this will be equal to BC is 2.5, AC is 3. So from this I'll get sine theta. My answer is 0.833. This would be in terms of meter. Here I have sine theta. Now after getting this sine theta value, I will keep this as my second equation because I'll utilize it somewhere. Now as I have told previously, the distance of 1.5 meter, that is known up to this dotted line. For calculation of h bar we require this small distance. Now for this small distance, again we can say that theta will remain same. We can calculate this distance also, and here I'll say that again onto the next page. From the geometry of figure alongside, I'll draw the triangle again, which is a right angle triangle. This is theta. Now here I want to calculate this point. I want to calculate the distance here. This is B. Next I'll say this is M. Here I have A. This AM is, this would be the distance. It is half, that is half of the diameter, means this is the radius. So here I have 1.5 meter. Now here I want distance BM. Once BM is known, we can get h bar. Since sine theta is equal to opposite upon hypotenuse, opposite is BM, hypotenuse is AM. I want BM value here, so BM will be equal to this, AM will go onto the other side, AM sine theta. So therefore BM is, AM value is 1.5. Sine theta we have calculated previously, it was in equation number 2. The value, it is 0.833. I'll say that this is from equation number second. Now this is Bm, and after this I'll say that hence h bar is equal to 1.5 plus Bm. Here we can see this h bar is made up to from free surface till this dotted line, the distance is 1.5. In that I'll add this distance b to m, so I'll get the total value of h bar. So this would be 1.5 plus 1.5 into 0.833. So hence h bar value, this comes out to be 2.749 meters. Now after this we'll put all values in equation number 1 to get the answer of hydrostatic force. Put all values in equation number 1. So I'll put the values onto the next page and I'll show what we have written in equation 1. In equation number 1 we have F is equal to rho. Therefore F is equal to, rho is the density of water, that is 1000, into G is 9.81 into capital A is the area of this circular plate. We have calculated it in the data. Area is 7.068 into h bar. H bar we have just now calculated, it is 2.749 meter. So 2.749. If I multiply these terms, I'll get my answer of hydrostatic force as 190.62 into 10 raised to 3 Newton. This is the first answer. That is, we have calculated total pressure. Now center of pressure. Since center of pressure is given by, the formula is H star is equal to I suffix G. For an inclined plane, here we have sine square theta upon AH bar plus H bar. Now I'll keep this as my third equation. I need to know the value of Ig. So I'll say that therefore Ig is moment of inertia for circular plate, that is Ig. For a circle, moment of inertia is pi by 64 d raised to 4. So I'll put the values. Pi by 64, diameter is given as 3 raised to the power 4. So from this I'll get I suffix G as 3.976 meter raised to 4. Now after getting the value of moment of inertia, I'll put all values in equation number 3 and get the answer of H star. Put all values in equation number 3. So therefore H star will be equal to, it is Ig, that is 3.976 into sine square theta. Sine theta value we have, that was 0.833 and it is sine square, so 0.833 square divided by area into h bar. Area was 7.068 into h bar 2.749 plus h bar 2.749, and hence h star comes out to be 2.89 meter. This is the second answer. So now if we see in this problem, there were two questions. First, to calculate the total pressure. That total pressure is nothing but hydrostatic force. We have found out the value in answer number 1. That is, hydrostatic force was 190.62 into 10 raised to 3 Newton. Hydrostatic force is calculated. Next was H star. H star value, it is 2.89 meter. That is, at a distance of 2.89 meter from the free surface, the hydrostatic force would be acting. As we see, H bar value, that was 2.749. So just below this H bar, there would be the center of pressure somewhere here. At this point, the hydrostatic force would be acting. So in this video, we have seen how to calculate the total pressure and center of pressure for an inclined circular plate immersed in water.